Hi, this is Eric Basier, Director of Quantum's Tape Automation Product Group, and I'm going to spend a few minutes telling you about the new Scalar i6000 Dual Robotics feature that is coming out in December of 2011. The primary benefit of having dual robotics is to reduce library downtime by providing robotic redundancy. This is a dual robotics system in our labs in Colorado. Notice how the robot in the background is operating while the redundant robot is parked nearest to us. The parked robot sits idle and it's ready to pick up operations if the primary robot encounters an issue. Pretty straightforward. Now, some of our competitors in the enterprise space have had dual robotics for years, so what sets our design apart? First, we can add the redundant robot while minimizing additional floor space requirements. Let me show you what I mean. This is a Scalar i6000 configured for redundant robotics. Notice the control module in the center, the expansion module on the right, and a new type of module to the left of the control module that we call a parking module. We use the right half of the rightmost expansion module and the left half of the parking module as storage space for parked robots. Let's take a look inside the parking module and I'll show you what I mean. Here's a view inside the parking module with the front door open. Notice that the new robotics design is narrow enough so that it only takes up half of the space in the parking module when it's parked. The other half is accessible by the operating robot. By using only half of each module for the parking space, it means only one additional frame is required to support redundant robotics. And remember that the i6000 module is the same size as a standard 19-inch data center rack. This is one of the things that sets our design apart. Another thing we've done is we've gone to a wireless robotics design for robotics communication and power. We've modernized the technology and we've eliminated belts for horizontal travel, making the design simpler and more reliable and enabling additional scalability in the future. Here's a close-up view of the power rails that the robots travel on. One other thing that the wireless design enables is improved serviceability, which brings us to the third element that sets our design apart, the ability to swap a parked robot in seconds. This is critical for those customers that cannot tolerate downtime, even during a planned servicing of a parked robot. To swap a parked robot, first open the module door, unhook a couple of latches, and then simply remove the parked robot. During this time, the operating robot is not moving for safety reasons, but the library continues to respond to the host application so that this swap is non-disrupted. Next, install the replacement robot. All of the mechanical features were designed to be self-aligning to make it easy for a service person and eventually a customer to be able to replace a parked robot. Once the robot is slid into place, slide the assembly to the right, and now it's locked in on its rails. Complete the process by reattaching the power rail communication at the bottom of the assembly via a couple of thumb screws, then re-engage the center rail latch, shut the door, and you're done. So let's recap. The benefit of dual robotics is that it reduces library downtime. Our design provides this benefit while minimizing the additional floor space that's required. We've gone to a wireless robotics design to enable improved scalability, reliability, and serviceability, and the design enables you to swap a parked robot in seconds. Oh, and one more thing. Once you have two robots, it's pretty easy with some code updates to make them both operate at the same time. This is coming on our roadmap next year. The Scalar i6000 dual robotics option is available starting in early December, and of course is backwards compatible with any fielded system. Thanks a lot for your time.